here we go. 3.3. Everybody at home can see. Everybody in here can see. Long division of polynomials. Guys, long division. You guys know what long division is. You've seen it before. Long division, if I had like 6 into 117, you tell me 6 goes into 11 one time, right? 11 minus 6 is 5. Bring down the 7. 6 goes into 57 9 times. 54. 3 left over. What is 3 called? The remainder. You would say 19 and then 3 over 6, which would become 1/2, right? Same exact concept we're going to do right now with long division polynomials. When you read this, it says 6x squared minus 26x plus 12 divided by x minus 4. So the x minus 4 goes on the outside. On the inside, 6x squared minus 26x plus 12. Okay, we got to make sure that every space is accounted for underneath our division bar. So it says 6x squared, then you have an x, then you have a constant. So that's that way that you guys need to make sure that it's like that all the time. Now, when we do long division, you guys are on your test, you're going to have a couple that are going to say solve using long division and then some that are synthetic. Synthetic division is a good way to check your long division, but you're going to have to be able to do long division. So the first thing you do is say first term into first term. So over here, I like to do a little side work. I say x times what gives me 6x squared? What would it be? 6x. So I'm going to write my 6x above my 26x. Keep everything in order. Now, before I go to do my multiplication, I'm going to get my subtraction ready. And we'll talk about this in a second. But now when we multiply, 6x times x is 6x squared. 6x times negative 4 is minus 24x. Now, guys, when we multiply and divide, we just use signs like normal. But when we add or subtract, guys, remember, when we subtract polynomials, what do you have to do with this negative sign before you can combine like terms?
You have to distribute it.
You got to distribute it. So at this point, you have to go through, and before you subtract or anything, you have to change. You got to change all the signs. If you don't do that, your answer will not be correct. So when we do that, negative 26 and 24 gives me negative 2x. My 6x squareds cancel out, and then you bring down 12. And then you do the process all over again. First term into first term. X, God bless you, times what gives you negative 2x? Negative 2. So I put negative 2 here before I do my multiplication. Let's get our subtraction set up. So I remind myself that I have to distribute that negative. So I'm going to say, didn't I write the 2 there? Where'd it go? So I say negative 2 times x is negative 2x. Negative 2 times negative 4 is plus 8. So like we just said, before we can subtract or combine like terms, we have to change. So I have 12 minus 8 is 4. What happens to my 2 x's? They cancel out. Do I have anything left to bring down? Do I have anything left over here to bring down?
No.
No, so 4 is my what? My remainder, my leftover.
Remainder.
So I would say 6x minus 2. Is that a positive 4 or negative 4? It's positive, so I'd say plus 4 over, what do we divide by? X minus 4. And then that's it. The process is super easy. It's the same thing every time. Where you guys will make a mistake is your signs. You'll forget to distribute, something like that. And as soon as you add something when you should have subtracted, or subtract when you should have added, that's where everything gets all messed up. Let's look at this one. This one says synthetic division. I want to do long division first. Okay, when I do long division, I'm going to have x minus 3 on the outside, and then underneath, remember, we cannot have, it has to go, if I start with x cubed, right? This starts with x cubed. All right, so then what's the place that's x squared? It's negative 7x squared. Is there an x? No, so you have to put a placeholder. I'm going to put plus 0x. You can put minus if you want, but you have to have a placeholder. And then at the end I have plus 5. If you forget this little placeholder here, the whole problem's going to be wrong. Whatever you start with, degree-wise, exponent, there has to be a place for every single one behind it. If there's not, then you just have to write it in. So let's say first term into first term. X times what gives me 2x cubed?
2x.
2x squared. So I'm going to put it above the squared. Now, before we do our subtraction, before we multiply, let's get our subtraction set up. So I multiply here. 2x squared and 2x gives me, 2x squared and x gives me 2x cubed, good. And then 2x squared and a negative 3 minus 6x squared. Now, before we combine, what do we have to do? Distribute. So I'm going to change, change, change. What's a negative 7x squared and a positive 6x squared? Negative x squared. What happens to my 2x cubes? They cancel down. Cancel out. And then what do? We bring down our 0x. So we're going to combine like terms, cross out what crosses out, and then bring down. And then we do the exact same thing again, guys. First term into first term. So I say, okay, x times what gives me negative x squared? Negative x. Good. So I'm going to have a negative x. Now let's get your subtraction all set up before we multiply. Negative x times x is negative x squared. Negative x times negative 3 is plus 3x. Before we can combine like terms, what do we have to do? Distribute. Good. So I'm going to change, change, change. 0 minus 3x is negative 3x. What happens to my x squareds? They cancel each other out. And then what do I do with 5? Bring it down. And now we do the same process another time. First term into what? First term. So x times what gives me negative 3x? Negative 3. Good. Before we subtract, or before we multiply, let's get our subtraction set up. So now we multiply. We're going to say negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Now look, guys, if you forget to distribute the negative, right now you have negative 3 and a negative 3. Do those just automatically cancel out? No. So you should think to yourself, okay, I've got to get this to cancel out. I got to change this, and then change that. So what's 5 minus 9? Negative 4. What happens to my 3x's? They cancel out. Is there anything left to bring down? No. So I'm left with 2x squared minus x minus 3 minus 4 over x minus 3. I know all of you have seen this. I know some of you are saying, I never got this last year, we did it. That's okay. You have to practice this. There's some of you that are like, oh, I get this, it's easy. That's good too. This right here, to me, is like some of the most important work. You guys don't have to do that. I do that because it makes me see things a little better. When I write the first term that I'm using into the first term that's going into, I can see what I have to multiply by. That's the only reason I do that, but you don't have to. All right, when we talk about synthetic division, guys, all right, remember synthetic division from Algebra 2? Anybody? All right, let's look at it. This is the same problem we just did, but they're telling us to use synthetic division. So when they ask you to use synthetic division, sometimes they'll tell you P equals a number, X equals a number, whatever. They didn't in this case. They're giving me an expression. So the first thing you do is you set that expression equal to 0. So I find out that X equals 3, positive 3, okay? So I'm going to take positive 3 and I'm going to put it in a little box up here. Now we take the coefficients of everything. So I say, okay, start off with x cubed. What's the coefficient of x cubed? It's 2. What's the coefficient of x squared? Negative 7. What's the coefficient of x? 0. Good. There isn't one, so put a 0, and then you have your 5. If I were you, as you're doing your synthetic division, if you start off with x cubed, say in your head, okay, coefficient of x cubed, boom. Coefficient of x squared, boom. Then when you say coefficient of x and you don't see one, it should remind you, oh, it's 0. But if you forget that 0, it's going to change your answer. So in order to synthetically divide, what we do is we bring that first term down, We multiply to the corner. So 2 times 3 is 6. And then we add down. Negative 7 plus 6 is negative 1, right? Multiply to the corner. Negative 1 times 3, negative 3. And then we add down. What's 0 plus negative 3? Negative 3. Multiply to the corner. What's negative 3 times 3? Negative 9. And then we add down. What's 5 minus or plus negative 9? Negative 4. Now you guys look at that and go, okay, now what? There's your answer. You can write this in polynomial form. What you just did was you found the coefficients of all of your variables. When we multiplied x into x cubed, right, we said it was x squared. Your answer is always going to start 1 degree less. So if I started here and my problem started out as x cubed, that means my answer is going to start out 1 degree less. So this is the x squared column. This is the x column. This is the constant. And this is the remainder. So you would literally write this out as 2x squared minus x minus 3 minus 4 over x minus 3. Is that the exact same thing that we just got 2 minutes ago when we did long division? Yes. So if it just says to divide, you can do whatever you want. But if it says to divide using long division, then you have to do what? Long division. If it says use synthetic division, you have to use synthetic division. All right, we're going to do 2 more examples and then we're done. This question is asking you 2 things. The first thing it says is find the quotient and the remainder of p of x when it's divided by x plus 2. Then the second thing says use the remainder theorem to find p of negative 2. All right, when you do your division, you will find b. So the first thing I'm going to do is say, okay, x plus 2 goes on the outside. On the inside, I have 3x to the 5th. Then I have 5x to the 4th. 4x third. Do I have an x cubed? Or I mean an x squared? Oh, wait a second, time out. You can do long division, but you don't have to on this one, right? Doesn't it say synthetic division? Yeah, remainder theorem. I'm sorry. You could use long division, but you don't have to. All right, if I'm going to use synthetic division, what's the first thing I do here with that? Set equal to 0. So in the corner of my little box, I'm going to put a negative 2. Now I'm going to write out the coefficients of all the variables. So x to the 5th coefficient is 3. X to the 4th coefficient is 5. Negative 4. What's the coefficient of x squared? 0. Then I have 7. Then I have 3, right? If you need to remind yourself, go through. This is 5, 4, 3, 2, 1, 0. Okay, good. For synthetic division, we bring down the first term, and then we multiply. Multiply to the corner. 3 times negative 2 is negative 6, and then you're going to add down. So 5 and negative 6 is negative 1, right? Negative 1, negative 2 gives you 2. Add down. Negative 4 and 2 is negative 2. To the corner, negative 4 and negative 2 and negative 2 is 4. Add down, you get 4. Go to the corner. 4 times negative 2 is negative 8. Add down, negative 1. Negative 1 to negative 2 is 2. Add down, you get 5. So if you were going to write the quotient and the remainder, okay, that is the coefficient. Those are the coefficients of all of your variables. So if I started out with x to the 5th, then my answer is going to start out as x to the 4th, right? So when I would write this out, you would write 3x to the 4th minus x cubed minus 2x squared plus 4x minus 1. And your remainder would be plus 5 over x plus 2. On WebAssign today, when you do this, they're going to ask you for the quotient and the remainder. They're going to have 2 separate boxes. So they want this in the quotient box and this in the remainder box. When I ask you to do it, I want it all together.
Miss Meadows.
What's up?
So
Good question. For letter B, they're saying using the remainder theorem. When they say using the remainder theorem, what do you think the only thing they care about is?
remainder.
The remainder. So you would say, okay, P of -2. Well, we just used -2. Right? We just did all this. What is the remainder when we did this?
5.
So your answer would be P of -2 is 5. When they say use the remainder theorem, they want you to do synthetic division, but the only thing they care about is the remainder. That's it. So if you have a question that says using the remainder theorem, you do all of the synthetic division, but the only thing that matters is the remainder. Make sense? We okay? All right. When they talk about a factor theorem, you guys are going to have questions on WebAssign, and it'll say is or prove. Whoops, I don't know what just happened. Okay, it's going to say is or prove that something is a remainder, that a number, I'm sorry, is a factor. All right, you're going to prove that something's a factor. The way that you prove it's a factor is this. All right, they're telling me to show that P of 1 is 0. What that means is put the 1 in the corner. Now let's do synthetic division, okay? What is the coefficient of x cubed? 1. What's the coefficient of x squared? Of x squared, 0, good. Of x, -7, and of 6. What's up? Question was, do you always, it just happens the last two at work like that, but you put a 0 for whatever variable is not represented. So since I start with x cubed, there has to be something in the place of x squared, of x, and a constant. If there is no x squared in the equation, then you put a 0. If there's no x, you put a 0. So if I do my synthetic division, I bring down 1. 1 times 1 is 1, and 0 plus 1 is 1. So 1 times 1 is 1. -7 plus 1 is -6. -6 times 1 is -6. -6 and +6 is 0. The remainder theorem states, the factor theorem states, when your remainder is 0, if the remainder is 0, then the number given is a factor. So if they give you a number and say, is 6 a factor of this equation? Is -4 a factor of this equation? You use your synthetic division and you work it out. If your remainder is 0, that means it goes into it with nothing left over, no remainder. So you would say, yes, something is a factor. The time that something is a factor is when the remainder is 0. All right? So when they say remainder theorem, they mean, what's the remainder? If they say is something is a factor, then the remainder has to be 0. Does that make sense?